take a look at solving equations and inequalities with this idea of absolute value. Now, most of the time when people are dealing with absolute value, they think, oh, it always is positive. Yes and no. That's kind of the wrong idea to have in it, that it always switches it to positive or switches the sign. Absolute value is simply the distance from a number to 0. So if you think about it, you drive forward, you're going to go a distance. You put it in reverse, you back up, you are going to go a distance. It's always a positive value. The distance is always positive. So that's the idea that we got to deal with when we're working with absolute values. So I want to solve this. The absolute value of some number minus 6 is equal to 4. What we need to remember here are two things. There's always going to be a positive and a negative of this. That is true, and that is true, correct? Absolute value of negative 4 is 4. The absolute value of 4 is also 4. So, that means that either x minus 6 is going to be equal to negative 4, or x minus 6 is equal to 4. Does that make sense to you? Because all we're doing is saying what's here on the inside has to be one of two things. It either has to be this, or it's going to be that. I kind of clear it up a little bit. Either what's inside there has got to be a negative 4 or a positive 4. Either one of these will work. So what we do is we take what's on the inside here and set it equal to the positive and negative of what's on the outside. So we go through and solve. Add 6, add 6. That means x is going to be equal to 2. Add 6, add 6. X is equal to 10. So, let's give this a try. If I go and put 2 in for x up here, if I put this 2 here, what is 2 minus 6? Negative 4. What's the absolute value of negative 4? 4. If I go and put 10 in for x, what is the absolute value? Or 10 minus 6 is 4. The absolute value of 4 is 4. Now, this idea is going to be extremely important, especially if you move into C and C word, because you've always got a tolerance. You want to go and put in, you drill a hole and run a 1/4-inch bolt through it. If they're exactly the same size, will they fit? Does there have to be a tolerance between the bolt and the hole size? Because you take a look at a 1/4-inch bolt. A 1/4-inch bolt isn't exactly a 1/4 inch for the diameter. It's got to have a little bit of a tolerance in there so it slides in there. Otherwise, the top and the hole in the bolt never fit. Okay? And if they would fit, it would require a little help to go in, sledgehammer, ball peen, whatever. So there's got to be a tolerance in there, and that's where this idea kind of gets used in. So, let's try this. I want to solve this. I need to know what the absolute value is equal to. So before I go and figure out what goes inside the absolute values, I need to figure out what the number is out here. So what I'm going to do is I'm going to add 5 to both sides, add 5. So I get the absolute value of 2x plus 4 is equal to 6. So now, I know the absolute value has to be equal to 6. What two numbers do I take the absolute value of to equal 6? Negative 6. 6. So, I know that either 2x plus 4 is going to be equal to 6, or 2x plus 4 is equal to negative 6. Those are the two possibilities. Subtract 4, subtract 4. 2x is equal to 2. Divide by 2, divide by 2, x is equal to 1. Subtract 4, subtract 4. 2x is equal to negative 10. Divide by 2, divide by 2, x is equal to negative 5. So, what we say here is if x is equal to 1, this should work. So if I put 1 in here for the x, 1 times 2 is 2. 2 plus 4 is 6. Absolute value of 6 is 6. 6 minus 5 is what? 1. Put in negative 5. Well, 2 times negative 5 is negative 10. Negative 10 plus 4 is negative 6. Absolute value of negative 6. 6. 6 minus 5 is 1. So that thought process should be a big deal for you guys because you like doing things in your head. Okay? But this is how it gets figured out. Yes. Absolutely correct. There's got to be one of two. Okay. Or you could even write it as x is equal to 1, x is equal to negative 5, but there's this idea of or. Either one of those numbers will do. Okay. And sometimes you'll see the answers just written as x is equal to 1, comma, negative 5. As long as you can identify that there's two different values in there, you're absolutely right. Let's try another one. I want to solve this one. Now, you're looking at this thing and you're saying, well, hold a sec, how can an absolute value be equal to a negative number? It's not a problem. There's just a few other things that we end up having to deal with. So, first offhand, what do I got to do? The absolute value of some number has got to be equal to negative 10, correct? The absolute value of another number has got to be equal to negative 10. How does this work? What do I have to do? Well, is there anything outside of that absolute value here that works? What would I have? Would I have to add in something? And if I do add in something, is that legal? I'm not sure. Think about that for a second. Would it be legal to add something into an equation to make it work, to give it more information? Okay. Is that legal for us to do that? You think so? Can I change the equation in order to make this work? No. There is nothing out here that allows this negative to work. The absolute value always has to come out as a positive value. I don't see anything out here. Now, what happens if I would have this? Could I make it work now? I could, because this negative out here would be the same as that negative here. So, you see something like this, where you get the absolute value, and it's equal to a negative value, it won't work. So this would just simply be no. solution. That would be your answer for that. You can't do it. Okay. And sometimes this will occur. So you have to be able to be aware of it. Think about it and say, hey, well, no, that can't be because the absolute value must be a negative. Must be a positive number. It cannot be a negative. So, let's try this one. Okay. Well, is it possible for the absolute value to be equal to 6x? Actually, yes. Okay. Basically, what this means is that either the absolute value of 6x is equal to 6x, or the absolute value of negative 6x is equal to 6x. Hey, it's positive, right? Okay. I can't go and take negative 10 and put I can't do the absolute value of something and make it negative. I can make the absolute value always be positive, and since this thing looks positive, I can do this. So that means that either 3x plus 18 is equal to 6x, or 3x plus 18 is equal to negative 6x, right? Because if I put 6x in, the absolute value of 6x is 6x. The absolute value of negative 6x is 6x. So I'm going to go and do the math and figure this out. Negative 18, subtract 6x, subtract 6x. So I end up with negative 3x is equal to negative 18. Divide by negative 3, divide by negative 3, and x is equal to 6. Right? Subtract 18, subtract 18, add 6x, add 6x. So I end up with 9x is equal to negative 18. Divide by 9, divide by 9, x is equal to negative 2. I got my answers, right? Now, every time that I've done this, I've also gone back and plugged it in and checked to see if this was actually going to work. So, let's try this with 6. Well, if I put 6 in over here, that would give me 36, correct? 6 times 6 is 36. So, if I put 6 in here, what's 6 times 3? What's 18 plus 18? What's the absolute value of 36? 36. So 6 works. What about negative 2? What is negative 2 times 6? Negative 12. Whoa. Is there any way that we could take the absolute value of a number and make it equal negative 12? No, because we just got done talking about that we can't do an absolute value of a number to make it negative 10. So, this works, and this does not. Now, it is possible to do all of the math correctly and come up with an answer that don't work. In mathematics, this is called an extraneous solution. And these are possible. Okay? So, that's what it means by check for extraneous solutions. You got to plug it back in and see if it's going to work. If it works, great. If it doesn't, it's not going to be there. Okay? So, that sort of kind of makes sense. Always have to check the work. Now, I realize that, back in the day when you were saying, oh, do I got to check my work? Well, yeah, you got to check your work. This is the reason why. Because it is possible for it to be a solution that's possible. So, let's try this one. Okay. Now, again, we are going to do exactly the same thing. This is 2 out here. So either absolute value of, absolute value of 2 is less than or equal to 2, or the absolute value of negative 2 is less than or equal to 2. This is correct, right? Those are the 2 possibilities that we can get out of this. So, now we have to go through and find ourselves the numbers that actually work for this. So, we are going to take x minus 5 is less than or equal to 2. X minus 5 is less than or equal to negative 2. Those are the two possibilities we came up with. Okay? So, add 5, x is less than or equal to 7. Add 5, x has to be less than or equal to 3. Okay. Now, here we go. Because it says the values have to be, x should be less than 7. So if I put 7 in there, will it work? What's 7 minus 5? 2. Is the absolute value of 2 less than or equal to 2? Yep. Let's pick a value that is less than 7. Let's put 5 in there. Is 5 minus 5? Well, that's 0. Is the absolute value of 0 less than or equal to 2? Yeah. Less. 0 isn't equal to 2. So let's try another one. Let's try a number that's even less than 3. Let's put 1 in there. Is 1 less than 3? Yeah. 1 minus 5 is negative 4. The absolute value of negative 4 is 4. Is 4 less than or equal to 2? No. We've got a bit of a problem here. Now, remember that bit when we were dealing with a negative and inequalities, we had to flip things around? We have to do the same thing here. So, my positive 2 works like a charm. This is the one that doesn't work. So what I need to do is I got to flip it around. Because I got the negative 2 here, we're going to flip that. So, when we go and put the negative in, write this down, put a note in there for yourself. Flip it. Okay. Because values that are larger than 3 and less than or equal to 7 work. Now this gets back to that idea of that tolerance again. You have to go and machine something that has specific tolerances. This is generally what happens, is your tolerance has to be between a certain range. Now, when it says graph the solution, that's easy enough to graph. We would just simply put 3 here, we'll put 7 there. This will be a closed circle, that'll be a closed circle, and everything between is shaded. Okay. Nothing new from what we've seen before. Why you type it? I should see you hiding in the paper. So, sort of kind of makes sense. Let's try another. So, all of the rules that we've applied up to this point in time still work. Now, do I just have the absolute value on one side and a number on the other side? And the answer would be no, so I got to do some fixing. So I'm going to subtract 4, so I get negative 2 absolute value, 3x greater than or equal to 2. Now I have to divide by negative 2, divide by negative 2, so I get the absolute value of 3x on this side, less than or equal to, because remember, multiply or divide by an inequality, flip it around, negative 1. Because in order for the system to work, we need to have absolute value on one side, number on the other. So, now we're going to go and set this up again. Now, I've got a question for you. Once we're looking at this, is it possible for the absolute value of a number to be less than negative 1? Because all numbers that are less than -1 are negative, yes. Can we get the absolute value to become negative? No. So this would be no solution. So you've got to be careful about that and see if it's even possible to do. Always kind of nice when you get something like this, right? You don't have to do any more work. You see, okay, this is the first one. But you got to get it like this. Now, let's try this. Next. Okay. Here we go. We got an absolute value and a number on one side. So that means we got the absolute value of 9 is greater than 9. Or the absolute value of 9 is what? We got -9, but if I put the negative with it, what do I got to do with the sign? Flip it around, so it's got to be less than. Okay. So these are the two things that we're going to come up with. We got 2x minus 5 is going to be bigger than 9. Okay. Then we've got 2x minus 5 is less than. So we got those two things that are going on. So far, so good? But always. There we go. Is that better? I probably would have caught it when I tried to add 5 to both sides. Add 5, add 5. I end up with 2x is greater than 14. Divide by 2, divide by 2, x is bigger than 7. Add 5, add 5. 2x is going to be less than -4. Divide by 2, divide by 2, x has to be less than -2. Whoa. How can I have a number that's bigger than 7 and negative and less than -2? Is that possible? And the answer would be no. That's why they're calling this one a disjunction. Now, a disjunction, it's or. One or the other. Perfectly legal. We can pick the numbers and we'll see that this actually does work. So I'm supposed to graph this out here. So if I graph this solution out, that means -2 would be down here, open circle, shaded this way. 7 would be up here, open circle, shaded this way. Okay? So, let's check. Give me a number that's less than -2. -3, okay? So if I put -3 up here for x, well, let's see, -3 times 2 is -6. -6 minus 5 is -11. The absolute value of -11 is 11. Is 11 bigger than 9? Okay. Give me a number that's bigger than 7. 10. 2 times 10 is 20. 20 minus 5 is 15. Is the absolute value of 15 bigger than 9? Okay. So, a number less than 2 worked, a number bigger than 2 worked. Let's pick a number that's between -7 and -2 and 7, because that should work. So give me a number. 4. 2 times 4 is 8. 8 minus 5 is 3. The absolute value of 3 is 3. Is 3 larger than 9? No. So this is a perfectly legal situation. Either x is greater than 7 or x is less than -2. Okay? And this is why it's important to go and pick the numbers, plug them back in, and see what you get. So, let's try this one. Okay. Okay. So now, I've got that negative on the outside. I got to get rid of it, right? So, if I go and multiply both sides by a -1, negative times a negative is positive, so I got the absolute value of 4x minus 2. This is going to have to be -1, but the inequality gets flipped around, right? So now I am looking at 4x minus 2, the absolute value. Is there a number that I can plug in here that is going to create a number that is not larger than negative 1? Or will any number I plug in here work? Because the absolute value always makes it go what? Positive. And will any positive number be bigger than negative 1? No. So this would be all reals. So when we get a situation like this where all the numbers are possible, all reals. A lot of this stuff is just looking at it, and if you've got the skills down for doing the algebra manipulation, everything else is fine. You're going to get an answer that looks like, is it right? Pick a number, check it. All. So, let's take a look at this. Absolute value function graph. We're used to looking at lines going up and down like this. Now an absolute value function is going to look like this. One of the things that you're eventually going to have to figure out and understand is there's something called parent functions. Okay? Now a parent function is the simplest function of a particular type. Okay? Every other graph can be made off of it. So the only graph that looks like this, that has this V shape, is the absolute value. Anytime you have a graph that looks like this, it's going to be in this absolute value form. Now, it's just something I want you to be aware of. We'll deal with this more as we go on. So, what I want you to do now is I'm going to give you about a minute or so here, and I want you to go through and solve this one. Okay, so let's Noah, what values did you get for x? You chose not to do it. Bad idea. So, x plus 3 should be equal to what? No. What should x plus 3 be equal to? Okay. And I should have x plus 3 also equal to what? Now we solve for each one. X, subtract 3 here, subtract 3 here. X is going to be equal to 4. Subtract 3 here, subtract 3 here. X is going to be equal to negative 10. So, graph this out, all I would see is negative 10, close circle, 4, close circle. Okay? All right? That makes sense. this one. All right. No. I realize that you were picked on for the last one, but what'd you get for X this time? Yeah, you're gonna get picked on. What'd you get? Did you do this one? Okay. So, somewhat, what did you do? Tell me what you did. I would recommend that you follow along with my examples. Actually, this one would be the same as that second example. So, I would recommend following along rather than watching videos. Texting. Subtract 5, subtract 5. Absolute value of 3x minus 3 turns out to be equal to 3. So, does anybody want to wager or guess what the x's are supposed to be? What you got, sir? 1? Just 1? Okay. -1? Yeah, but shouldn't you get 2 answers? What you got, Jordan? 2. And ooh, okay. Let's take a look at this. So that means either 3x minus 3 is going to be equal to 3, or 3x minus 3 is equal to negative 3. Add 3, add 3, 3x is equal to 6, divide by 3, divide by 3, x is equal to 2. Absolutely correct for that one. Now over here, we add 3 again, add 3 again here. I get 3x is equal to 0. So it's not division by 0, but it's 0 divided by 3. Means x is equal to 0. So those are your 2 possibilities. So let's check this now. If I go and put in 2, what is 3 times 2? 6. What is 6 minus 3? 3. What's 3 plus 5? 8. Did it work? Yes. Let's put 0 in here. What's 0 times 3? 0. What's the absolute value of negative 3? 3. What's 3 plus 5? 8. So, is it possible? No. Why? That negative sitting right there. No solution. Okay? So, let me give you a minute. I want you to do this one. I'll do this one for the sake of argument, right? So either 4x minus 1 is equal to 2x, or 4x minus 1 is equal to negative 2x. And, hold on a second, I don't want that. I want to be sneaky about this. Subtract 4x to both sides, subtract 4x, that gives me negative 1 is equal to negative 2x, divide by negative 2, 1 is equal to x. Subtract 4x, subtract 4x. Negative 1 is going to be equal to negative 6x, divide by negative 6, divide by negative 6. So 1/6 is equal to x. You don't like that one? Yes, there is. Check. Let's put in 1. 4 minus 1, or 4 times 1 is 4. 4 minus 1 is going to give me 3. The absolute value of 3 is 3. Is that going to give me 2? 2 times 1 is 2. So does 1 work? What about 1/6? Well, let's see. If I put 1/6 in up here, that gives me 2 over 6, which is 1/3. If I put that in up over here, that's going to be 4 over 6, which gives me 2/3 minus 3/3. What's the difference between 1/3 and 3/3? 1/3. Absolute value of 1/3 is 1/3. So this is a yes.